The biggest difference between Juno and previous missions to Jupiter is we're really focused on the planet, not the Jovian system. The first missions to go to Jupiter, there was a lot to explore there, and it's a dangerous place, and so naturally stayed well outside the radiation belts and basically stayed in or near the equatorial plane of Jupiter. That's where the moons are, that's where there's a lot of stuff going on. Galileo spent a lot of time in the Jovian system. We learned all kinds of really cool stuff. We found a liquid water ocean under the ice on Europa, lots of things about the Jovian moons, but it wasn't primarily designed to study the interior of Jupiter, and it didn't. I mean, we dropped a probe in and we learned some cool things, and we tried to measure the water, and we measured a lot of other constituents and got some idea of the composition, and there were lots of puzzles that arose from that. But Juno's doing something different. Juno's coming in on a polar orbit over the pole of the planet, cutting inside the radiation belts really close, and then going out for a long time, for 14 days, and doing it again. So we take an hour or so from pole to pole, and then 14 days way out far from the planet, and do it again over and over. What that lets us do is carry an innovative suite of instruments inside the radiation belts, very, very close to Jupiter, in a place where no one's ever put instruments before.
There's a couple pretty interesting things that we're doing for the first time at Jupiter. The first of those is solar power. Nobody's ever flown a mission to Jupiter before that was not nuclear powered. But the technologies that have advanced in solar power since Galileo was launched years ago, they took a good look at making this mission feasible with solar power and found a way to pull it off. And I think that was one of the key enablers for Juno being selected. Every time Galileo flew through the radiation belts, they had issues. They had transients, they had unexpected problems. There have been many papers written about what they went through. And the closest that they ever got to the planet itself was what we call 4RJ, 4 Jupiter radii. Most of their orbits were 5RJ and farther out. So there's not a lot of data that we can rely on directly to determine what we're going to fly through, because we fly through so close to the planet, we're equivalently 1.07 RJ, only 5,000 kilometers above the cloud tops. Unlike some other missions, Galileo or Cassini, they had longer primary missions, and they also had the possibility, and in fact did indeed, have extended missions. We have 16 months with no extended mission on the books. When you go out to Jupiter, you have to deal with the environments, and the radiation field and the dose that accumulates over time ends up being a constraint on how long we can operate, especially given how much closer to the planet we operate compared to Galileo.